Yes, Ruben. Number 9. Okay. If I have to ask you to stop talking again, you will leave. No, if you yell my instructions after I have stated them again today, you will leave. And I will see you tomorrow. You will go hang out in the office for the rest of math. And they will ask why you are there. Here we go. So, Ruben has a question about, and this is actually great, because my A block asked me about number 9 as well. So let's do the A number 9. Here we go. So, yesterday, we looked at, Hayden Dunn, get your stuff out. We looked at distribution. This is page 12, Grail. So what we need to do on this question, I've got multiple sets of brackets. We need to make sure that we distribute each monomial onto its neighboring binomial. So first step for these things is going to be to distribute. I'm going to multiply this 2 in there and in there. Let's do that piece first before I do anything else. So multiplying these two things together, I need to make sure this 2 multiplies onto both these pieces. So 2 times n is just going to be 2n. And then 2 times negative 3 is going to be minus 6. Now I'm going to take this positive 10 here. I need to include the sign that's out front. Do you need a writing utensil, Ruben? Okay, you should run up to the front and grab a loaner book. And we need to distribute that onto both these pieces here too. So 10 times negative 3 is going to be negative 30. And 10 times negative 5n is going to be negative 50n. Hayden, stop talking. The negative 84 on the left-hand side hasn't been touched, so it just stays the way it is. Now, next step. If there are like terms, group them. There are like terms, so let's do that. I've got a 2n here, and its like term is what? It's negative 50. Yes. You have to include the sign out front. So 2n minus 50n is going to be what? Sweet. Negative 48n. The next set of like terms is going to be that. Thank you. And on the left-hand side, nothing has been touched. Got negative 84. Okay, cool. Now my like terms have been grouped. I want to isolate n. So I need to get rid of any terms that don't include it. Yes, Dilkaran. Get it by itself. Like when I isolate you, it means you're going to go sit somewhere else by yourself, for example. But you're not, Raven. Like when you go to the couch and sit alone, you're isolating yourself. So what I want to do first is to get rid of any terms that don't include the n. So that would be this negative 36 term here. To get rid of negative 36 on the right-hand side, what am I going to have to do? Yes. I'm going to do that to both sides. Negative 36 plus 36 is gone. I'm left with negative 48n plus 0. Adding 0 is not going to change anything. So then I'm going to have negative 84 plus 36. Negative 84 plus 36 is? Yes, it is, in fact, something. Sorry? I didn't assign 10. If this was positive 30, it would be negative 54. So now you're at negative 54. Go 6 more.
Yeah, negative 48.
It would be negative 48.
Oh, and then
which is beautiful, because now to get n by itself, I've got n times negative 48. I'm going to divide both sides by negative 48 to undo that. On the left-hand side, negative 48 divided by negative 48 is 1. So that's going to leave me with 1n. I don't have to write the 1 when there's a variable there. But on the left-hand side, Negative 48 divided by negative 48. Also 1, but now because that's the only thing there, I have to write it. There's your final answer. N equals 1.
Next page.
Okay, so Ruben, instead of the next page, instead of doing number 10, let's flip the page and look at number 11. Because it's also a question I assigned and it's exactly the same. Yeah, we're going to do number 11. But it's exactly the same. Number 11 is no different. So let's do, you want to do 11? Let's do 11. Okay, the first step is the same. I'm going to distribute in those 5s. Multiplies here and here, multiplies here and here. So 5 times 10 is 50. 5 times negative 8v is negative 40v. Positive 5 times 9v is going to be positive 45v. And positive 5 times 7 is plus 35. And this, of course, equals 80. Comments, questions, concerns about what I've done there? Now we're going to combine like terms. Ruben, what are the like terms? 50 and? There is no positive 5.
50 and 35.
And the positive 35. So that's going to be 85. And so that's that piece and that piece. What are my other like terms there, Ruben? Nope. There you go. Okay, so negative 40v plus 45v is? Negative 40 plus 45? It should be positive 5v. And that's going to equal 80. Now I'm going to take away 85 on both sides. I'm going to get 5v equals negative 5. We're going to divide by 5, and v is going to equal negative 1. And if we look at number 11 down there at the bottom upside down, that's correct. Ruben, does that make sense? Because I've got positive 85 here plus 5v. This is, I want to get v by itself, so this is what needs to move. So I have to subtract 85 on both sides. Okay. Any other questions from the homework? Oh, there was more homework I assigned. This page was optional. Okay, and here's the other piece. If you want to rewrite a chapter and I've given you optional work, it also needs to be done. So, if you want to rewrite this chapter test, you need to show me you've done the optional work.
Which says do good the first time.
So do well the first time, or be prepared to do a whole bunch of work to get practiced up. So, that was optional. This was optional. This was not. What were the headlines after a midget fortune teller escaped from jail? I realize this is wildly politically incorrect. It makes perfect sense. Yeah. What were the headlines after a little person? What? How did they correct it online?
It was the same headlines, but like the question was instead of midget, it said 3'10".
Yes.
Yeah.
Yeah. They changed it to a shorter height. This word midget, yes, I know it's not politically correct. I apologize if I offended anybody. The answer is the same. The answer is small, medium, at large. So a medium is another word for a fortune teller.
Oh, that's...
They are a small fortune teller because they're 3'10", and to be at large means you've escaped from prison.
Medium didn't make sense.
A medium is another word for a fortune
I
teller.
didn't know that.
That's the key there. And why do girls like guys who wear shirts with 8 buttons? They fascinate. Well, except they have 8 buttons. So they fascinate or they fasten 8. There you go. Yeah. See? Yep, sometimes you just gotta go slow. That's okay. And this was optional too. This page did not have answers for it. Anyway, what is this? Okay, flip ahead to page 1. We've looped around the numbering. We're back to page 1. Let's see if we can get this lesson done and still get you guys some time to practice. Here we go. Today we're going to look at fractions. I am going to give you 2 techniques for dealing with fractions. Dilkaran, eyes on the screen, please. You pick which technique you like and roll with it. I will demonstrate 2. Fractions can make our questions more difficult. Fractions make everyone's life more difficult. But there are ways to get rid of the fractions. And no, you don't just shove them through a calculator. Here we go. Here are the steps that I'm going to demonstrate. First, this is kind of optional. But if it helps you, go for it. What you need to do is you need to identify how many terms you've got. So an easy way to do that is to place brackets around each term. Once you get good at this stuff, I don't expect you to do that. But as long as you need to be able to identify how many terms are present. Then what you're going to do is multiply every term with whatever denominator is present. And then we're going to simplify that fraction. If there are, so this is where the star is because this is where things change. If there are 2 or more different numbers as a denominator, one of the techniques that we can use is to find the LCM. LCM stands for what? The lowest common, yes, multiple. That is the smallest number that all of the denominators multiply up to. Then you're going to multiply every term by that number, simplify and reduce the fraction. Or, there is a way around that. Instead of multiplying by the LCM, you can multiply by each, underscore the word each, underline the word each rather, each denominator. And simplify. And I'll show you how that's different. Some of you are sitting there being like, multiplying by the LCM and multiplying by each denominator is going to do the exact same thing. It does and it doesn't. Let me show you what I mean. You can end up at the same result with different techniques. Some of in my first block class, they're like, but you're doing the exact same thing, which isn't true. I'll demonstrate why it's different. Here we go. So these are questions I've given you already. X over 4 equals 3 and 19 equals X over 3. We've done that before. These are relatively straightforward because a fraction is just another way to write what operator? Division. So this is just X divided by 4 equals 3 and 19 equals X divided by 3. In both of these cases, these are single step solutions. To undo the division by 4 over here, what am I going to do? I'm going to multiply 4 on both sides. Multiplying by 4 and dividing by 4 are the same but opposite operation. So multiplying by 4 and dividing by 4 means this cancels, leaving us with 1. Or in this case, 1x. And then 3 times 4 is 12. I only had one term on each side. That's a super straightforward way to solve that question. The next one is the same. The denominator is 3. So to get rid of that denominator, I'm going to multiply both sides by 3. On the right-hand side, the 3's are going to cancel, leaving me with x. Why was it there in the first place? Because some value divided by 3 is 19. What's the value is what we're trying to find here. So the value divided by 3 that gives us 19 is the same as whatever 3 times 19 was. Because doing it to both sides is going to give you a different value over here. Whatever you do to one side, you have to do to the other. We're trying to undo whatever operations are standing between us and a variable being alone. You're trying to destroy some relationships here. We're breaking up x and divide by 3. Okay, so these are straightforward. These you have done already. These are trivial. Let's move on to something slightly more interesting. Here we go. I've got one variable here, but now, how many terms do I have on the right-hand side? 2. So, the steps for this are, we outlined them before. What we want to do is when we are multiplying here, Hayden and Oliver, what we're going to do is we're going to multiply every term with the denominator we're trying to get rid of. Now, to solve for x here, we're going to have to divide, we are dividing by 2 on the x. Yes, I've got x's on both sides. Before we can even do anything with that, I need to make sure I get rid of this fraction. Fraction is the same thing. Oh, there's the, everyone's phone's going off right now. Yeah, everyone take out your phones.
I did it.
Yeah, it's a test of the emergency broadcast system. Tell your phone that you heard it, and now put it back. Well, that means the government doesn't want you to know when there's an emergency.
I knew about it, but I didn't go off.
Okay, put your phones away now that they've all stopped going off. Here we go. Because I'm dividing x by 2, I'm going to multiply everything by 2. Here's what that's going to look like. On the left-hand side, it looks as straightforward as it was before. On the right-hand side, we've got multiple terms here. There's 2 terms. So each term needs to be multiplied by 2. This guy's going to get multiplied by 2, and this guy's going to get multiplied by 2. Whatever I do to one side, I have to do to the entire other side. So on the left, those 2's are going to cancel, leaving us with just x. On the right-hand side, let's do this multiplication. 3 times 2 is? 2 times x. 2 times positive x is positive 2x. So now I can go ahead and solve this thing. I want to get all my variables on the same side. So what am I going to do? We are not, do not divide by 2. Because we just got ourselves out of the mess of dividing by 2. We are, oh. So, because we have a 6 on this side already, it would make, unfortunately this is going to give us a negative coefficient, but it would make more sense to bring the x's over to the left. To do that, because we're adding 2x here, we're going to subtract 2x on both sides. That's going to leave us with the 6 alone on the right. And over here, it's going to leave us with what? X minus 2x is negative 1x. And I'm not going to write the 1. Because you don't have to write the 1 when the 1 is the coefficient. So negative x equals 6. Now, I don't want negative x equals 6. I just want x equals something. So what am I going to have to do to get x positive? Divide by negative 1. The only thing dividing by negative 1 does is makes this thing positive, and it makes this thing negative. So we're going to get x equals negative 6, and we're done. Oliver, stop talking to Hayden. Let him click it. Okay. Questions about what I've just done? The only new piece is the multiple terms thing going on here. Okay, let's up the ante a little bit, shall we? I've got 3 questions here that have multiple denominators. I told you, there's going to be 2 different techniques. So I'm going to demonstrate the LCM technique here first, and then the other one down here. Okay, let's take a look at this one. What is the lowest common, so we've got 2 fractions here. I've got over 4 and over 3. What is the lowest common multiple of those denominators? The lowest common multiple of 4 and 3 is 12. 12 is the smallest number that 4 and 3 can both multiply up into. So having identified the LCM, the first technique is multiply every term by that LCM. So I'm going to multiply by 12. I'm going to multiply over here by 12. I'm going to multiply over here by 12. Every term needs to make sure it gets that action. So, how do you multiply a whole number by a fraction? Yeah, the whole number over 1, I heard of several people say, and then multiply numerator, multiply denominator. Dilkron, don't ask me any questions if you're not paying attention while I'm going through the questions. So over here, 12 times x is 12x, 1 times 4 is 4, equals 12 times 5 is 60, 1 times 3 is 3. And then minus, because it's just 2 times 12, 2 times 12 is 24. And now, I'm going to simplify each fraction. What's 12 over 4? That's the same as 12 divided by 4, which is 3 over 1, which I'm just going to write as 3. So this is going to become 3x equals, what's 60 divided by 3? 20. And then the negative 24 isn't a fraction, it's just minus 24, so we're done. Well, done dealing with fractions. Now what's next step, Delcaron? Like terms. What's 20 minus 24? So we're going to get 3x equals negative 4. And then the last step here is to get x by itself by dividing by 3. So x equals negative 4/3. And for those of you who hate fractions, negative 1.3 repeating. Seen you a lot today, Mr. Federley. Ah, yes. I did see that as well. Good luck. They roped you back into coaching again, eh? Questions about anything I've done here? Okay, so that's one way. Let me demonstrate the other way. Instead of multiplying by the LCM, the other way was, what we're going to do is forget finding the LCM. We're just going to multiply every term, Hayden, by every denominator. So I have multiple denominators down here. I've got a 2 and I've got a 3. So I'm going to multiply every term by 2 and 3. Times 2 times 3 times 2 times 3 times 2 times 3. And now this is where my other class, and I think Brielle just said it, isn't 2 times 3 6? Yes, 2 times 3 is 6, which would also be the LCM, but I've written it differently. Instead of multiplying by the and that has everything to do with how I'm going to do this differently. Multiplying by 12 means I had to write out the fraction and then reduce the fraction. Multiplying it like this and writing it out piece by piece allows me to do some pre-simplifying. Because look at what I've got here. I've got multiplying by 3, multiplying by 2, and dividing by 2. So the multiplying by 2 and the dividing by 2 are going to cancel right away. This piece and that are gone. Likewise, in the second fraction, I'm multiplying by 2, I'm multiplying by 3, and I'm dividing by 3. So what's going to cancel here? The 3's. So I'm not multiplying by an LCM and then reducing a fraction. I'm getting rid of the fraction in the first step. That to me is different enough that I wanted to show it to you separately. So now all I've got left here is 3 times x. That's just 3x. Here I've got plus 5 times 2. That's just going to be plus 10. And on the other side then, I've got nothing simplified here. So I've still got 2 times 2 times 3. So that's 12. By writing it out, instead of doing the LCM, by writing it out piece by piece, we get to skip that whole multiply to the fraction and then reduce the fraction step. Which, if you're comfortable with, I think is a big enough savings that it's worth showing you how to do. So now I'm just going to solve this thing for x. I'm going to get rid of any terms that don't include the x, so that would be this positive 10 here. I'm going to subtract 10 on both sides, leaving me with 3x equals 12 minus 10 is, and then I divide by 3, I divide by 3, and x equals 2/3. Comments, questions, concerns? Just because I'm interested, show of hands, who likes the LCM method better? Okay, Show of hands, who likes this better? You understand the bottom one, or they understand the LCM one more?
I understand the bottom.
Okay.
I just feel like a little bit more.
Perfect. Well, then let's do it. I'm going to do one more example, and then I'm going to free you to play. Okay, so last example. Hands up if you would like to see the LCM method again. Hands up if you'd like to see the other method again. Okay, so I'd votes for both. Let's do them both. Okay, so Charlie, what's the lowest common multiple of 2 and 3? No, multiplies up into. 2 and 3 both multiply up to. Yes, the muttering has started. Jackson, louder. 6. 2 and 3 both multiply up to 6. So that's going to be our LCM. I multiply each term. And in this case, there's 4 of them. I'm going to multiply each term by 6. What that's going to do is, I'm going to get 6x over 2 plus 30 over 3 equals 12 minus 6x over 2. Are we cool with what's just happened? Charlie, we're cool with what just happened? Okay. So now I'm going to reduce those fractions. 6 divided by 2 is 3x. Plus 30 over 3 is? Equals 12 minus 6 over 2 is? 6 over 2 is? 3x. Now I want to get all the x's to one side, all the numbers to the other. So to get the x's to the same side, the smart move here is to do what? Yes, add 3x to both sides. Because on the right-hand side, I've got a negative 3x plus 3x is gone. On the left-hand side, I've got 3x plus 3x, which is? You bet. So I'm going to get 6x plus 10 equals 12. I'm going to subtract 10 on both sides. I'm going to get 6x equals 2. Divide by 6, divide by 6. X equals 2 over 6, which can be reduced to what? Divide by 2, and x equals 1 over 3. That's why it's still on the screen. Okay, so real quick, I want to show you where the other way starts. So write out this question for me real quick again. X over 2 plus 5 over 3 equals 2 minus x over 2. Write that up here. I'm going to demonstrate where the other method goes different just to start. Instead of multiplying everything by the LCM, I'm going to multiply everything by the denominators. The denominators are 2 and 3. Yeah, there's another 2, but if I'm already multiplying it by it once, I'm not going to multiply it by it again. Okay? So what I'm going to do on this one is I'm going to multiply each term by 2 and 3 times 2 times 3, each piece. So because there's 4 terms, I need to multiply each term by 2 and 3. In the first term, what's going to cancel? The 2's. It's going to be 3x. In the second term, what's going to cancel? The 3's. So it's going to be plus 10. Yeah, it's exactly the same question. 2 times 2 is 4 times 3 is 12. Minus, what's going to cancel in the last term? The 2's. So it's going to be negative 3x. What this allows you to do is skip this whole first line. That's the only difference. Yeah, you're cutting out and when you're not reducing fractions, every step you're able to skip reduces a place for you to make a silly mistake.
So you don't have to do the reducing at the end.
This one you would still have to reduce at the end because this one just rejoins us right here. You skip this step, yeah. This will still take you down to x equals a third. Okay. The students are getting restless. Flip the page. Here's what I'm going to get you to do. There's 2 sections of questions. Because this is technically one big lesson that I'm breaking up into 2. Here's what I'd like you to do. Yes, odds. And I'm going to tell you what the answers are because there are no answers on this section. In no particular order, I want you to write down these numbers. -10, 8, 14, -26, 20, -15, and -20. There are 14 questions. I'm assigning odds. There are 7 numbers in that list. Do the math. No. So what I want you to do is flip 2 pages forward. 1, skip the binomial. Don't worry, Raven, I'll go back. This page, where it says lesson 5 homework at the top, I want you to do part 1 and part 2 ACEs. And there are answers to this page. Hayden, keep your hands to yourself, so help me. Not you, you're good. I will forever call you Glenn. The answers are, you also weren't touching anybody, so you're good. The answers for those 2 sections, if you flip 2 ahead, are down there at the bottom. We're going to do all the binomial stuff tomorrow. ACEs on part 1 and part 2. Part 3, 4, and 5 don't do because that's the second part of the lesson to tomorrow. And Raven, going back to it, I want you the odds on this page. That's your homework. You have 15 minutes to the bell. Please use this time. Only 15. Which means it's not worth your time to walk downstairs. Get to it. Yeah, by all means, use whiteboards. Sorry, Ruben? What? Do what you gotta do. Okay, get to it. I'm done teaching at you. You are free. Yes.